So here's number 2 from the Chapter 5 AP packet. It says, let f be a twice differentiable function defined on the interval from -1.2 to 3.2, with f of 1 equals to 3. So when I see that, I see an initial point that I'll probably be using somewhere. The graph of f prime, the derivative of f, is shown. So again, this is graph of f prime, not f. The graph of f prime crosses the x-axis at -1 and 3. So you can see that on the graph, but they do often explicitly say it again. And has a horizontal tangent at x equals 2. So now you do also know that at x equals 2, there is a horizontal tangent. Let g be the function given by g of x equals e to the power of f of x. So most likely, if it says let g be this function, this is actually a function I'm going to be using. F is just simply going to be used for certain values, but g is the one I'm focusing on. So part A, write the equation for a tangent line to the graph of g at x equals 1. Well, anytime we want a equation of a tangent line, we need a point and a slope. Specifically, the point will be g of 1, and the slope will be g prime of 1. Well, g of 1 is pretty easy. All you have to do is plug in 1 into e to the power of f of x. This is e to the power of f of 1, which is e to the power. Now, remember, they gave us f of 1. It's right there. It's e to the power of 3. However, if I want g prime of 1, well, I'm missing what g prime is. So I need to find the derivative. G prime of x equals, well, e to the power of f of x is e to the power of f of x. But using the chain rule, I also need f prime of x. So if I want g prime of 1, I need e to the power of f of 1 times f prime of 1, which e to the power of f of 1, again, is e cubed. But f prime of 1, so what I have to do is I have to go to the graph of f prime, this is the graph of f prime, and I need to find f prime of 1. Well, f prime of 1 is right there, it's -4. So then multiply the answer by -4. So finally the equation of the line would be y minus y1, which is e cubed, equals slope -4e cubed times x minus 1. And that is all. For the interval -1.2 to 3.2, find all values of x where g has a local maximum. Justify your answer. Well, if I want to prove that g has a local maximum, I need to prove g prime changes sign. And specifically, since it's a maximum, I want it to go from increasing to decreasing, so positive to negative. So let's see what g prime is. Now, I already found g prime from the earlier problem. G prime of x equals e to the power of f of x times f prime of x. So now the question is, when does this change sign? Well, I don't have a graph of this, but I do know certain properties. I do know, for example, e to the power of f of x is always positive. That will never change. So when I'm talking about just purely the signs, I only really need to focus on f prime of x. Well, I can see where f prime of x changes sign from positive to negative. It actually occurs at -1. So I'm going to use that as my justification. F prime of x changes from positive to negative at x equals -1. Since g prime of x equals e to the power of f of x times f prime of x, and e to the power of f of x is greater than 0 for all x, g prime of x will change from positive to negative at x equals -1. In part C, the second derivative is a given, so they were nice enough to explicitly give you the second derivative. is g double prime of negative 1 positive, negative, or 0? Well, justify your answer. The only thing you really have to do is dissect what is what in this problem. If there are any numbers I really need to care about, well then I can write those numbers down, but what I'm probably only focusing on is whether it's positive or negative. So let's start with e to the power of f of x. Well, we know that's positive for all x. That makes things a little easier because then I can just focus on what's on the inside. So let's look at f prime of x, and I can even look at the quantity squared. Now f prime of x isn't always positive and isn't always negative. But what I can look at is saying f prime of negative 1, because that's really the value I should be caring about. Well, f prime of negative 1 is, according to this graph, 0. So f prime of negative 1 equals 0. So therefore, f prime of negative 1 quantity squared equals 0. Okay, one more to go. F double prime of x, well again, f double prime of x doesn't show any behavior. And again, f double prime of x will be what f prime, this top graph, how it behaves, but at negative 1 specifically. So f double prime at negative 1. Well, since I'm not able to actually estimate what the slope is at negative 1, this slope, I do know, is negative. And because it's negative, I do know that f double prime of negative 1 is less than 0. So my answer will be that g double prime of x will be a positive number times 0 plus a negative number. Oops. Negative number. Which a positive times a negative is negative. So g double prime of negative 1, and that should be g double prime of negative 1, will be less than 0. And our justification really falls under showing our work. And we showed where we figured out what's positive, what's negative, what's 0. And therefore, I can pretty much figure out from here what happened. You showed me enough evidence to support your answer. All right, last one. D, find the average rate of change of g prime, the derivative of g over the interval. Do not overcomplicate this. The average rate of change of g prime would be saying, take the slope equation and apply it for g prime, where g prime is what y is. And it goes from 1 to 3. So what I should find is, what's g prime of 1? Well, I found that in part A, I believe. G prime of 1 was negative 4e cubed. And then what's g prime of 3? Well, g prime of 3 I never did find. So what I have to do here is use formula for g prime, which I found earlier, e to the power of f of 3 times f prime of 3. And the fact that they use 3 is really important, because if I look back at my graph, at 3, f prime is 0, which makes this whole term equal to 0. So then I do y2 minus y1 over x2 minus x1 and see what happens. So negative 4e cubed minus 0 over 1 minus 3, which is negative 4e cubed over negative 2, which is 2e cubed. There's our answer.